Determine whether the integral is convergent or divergent. Evaluate if convergent. The integral from negative infinity to positive infinity, cosine of pi t dt. This is an improper integral. We see that by the two infinite limits of integration. Since there are two limits of infinite limits of integration, this integral breaks up into two integrals. Integral from negative infinity to 0, say. In fact, you could pick any number that you want instead of 0, but 0 is usually pretty convenient. Plus the integral from 0 to infinity, cosine of pi t dt. Each one of these is an improper integral which requires a limit to evaluate. So this one is the limit as, a goes to negative infinity. Of the integral from a to 0, cosine of pi t dt. Plus, this one is the limit as b goes to positive infinity, the integral from 0 to b, cosine of pi t dt. So the limit as a goes to negative infinity. The integral of cosine of pi t dt is negative 1 over pi sine of pi t. And we have to evaluate that at the limits, the endpoints of the interval, which is from a to 0. Plus, similar thing over here, the limit as b goes to infinity, negative 1 over pi sine of pi times t, evaluated from 0 to b. In evaluating, we put in the upper limit of integration first. So we'd have negative 1 over pi sine of pi times 0 minus negative 1 over pi sine of pi times a plus the limit as b goes to infinity, negative 1 over pi. Here the b is the upper limit of integration, so pi times b minus negative 1 over pi sine of pi times 0. Okay. If we start talking about these limits, pi times 0 is 0. The sine of 0 is also 0. 0 times 1 over pi is 0. So this first term is equal to 0. The second term, however, we run into something that doesn't work very well. Notice that you're talking about the sine of pi times a. A is getting closer to negative infinity. If you consider the graph of sine looks like this. And this oscillates between the values negative 1 and 1. If a gets closer to negative infinity, pi times a also gets closer to negative infinity. Now, as the input of sine gets closer to negative infinity, travels to the left, the value of sine oscillates back and forth between 1 and negative 1. It never settles in on a specific value. So that tells us that the limit of this whole thing does not exist. In other words, the limit is divergent. If either one of these limits is divergent, then the entire integral that we started with is divergent. So we don't even have to evaluate the rest of this. We already know, because this part diverges, that the whole thing diverges. So the integral from negative infinity to positive infinity of cosine of pi t dt diverges.